Good morning, students. Myself, I'm Dr. Indira, teaching the course Probiotics in Functional Foods. So, today we will see the topic that is tolerance to additives. What are additives? Additives are nothing but the substances which are added to the formulating products. So, they are preservatives, stabilizers, coloring agents, sweeteners, emulsifiers, thickeners, so excipients. So these comes under the category of additives. So here the concept is tolerance to additives. So whatever the probiotic strains, probiotic organisms are there, they must show the tolerance to the additives what we are adding in the formulation of probiotic products. So for probiotics to be effective in various applications, they must demonstrate the tolerance to additives. So commonly used in food, pharmaceutical, and other delivery systems. So these are the various categories of additives used in probiotic food products and probiotic formulations like drugs and then dietary supplements. So research into the effects of food additives, encapsulation materials, stabilizers, and flavoring agents is vital for understanding how these factors will influence the probiotic viability. Viability is very, very important while you are marketing any probiotic product into the global market. So if the strain is viable, then the product has huge market. If it is non-viable and it won't show any activity, it won't show any efficacy, that product will fail in the market. So in order to maintain the viability of the probiotic organism, whatever the additives we are adding, this particular organism need to show the tolerance to these additives. So these components can either protect it or compromise the survival and functionality of the probiotics in various food matrices. So what are the key factors in probiotic tolerance to additives? So if you take preservatives, so the probiotic strains must resist the preservatives like sorbic acid, benzoates, and sulfides that inhibit the microbial growth. So these are the preservatives generally used in various food and dairy products. What are those? Sorbic acid, benzoates, and sulfides. So these strains must show the resistance towards this particular preservatives. Sweeteners and sugars such as artificial sweetener, that is the aspartame and then sucralose and sugars may alter the osmotic balance and impact in the cell viability. And come to the emulsifiers and stabilizers. These are the polysorbates and gums. They affect the integrity of the probiotic cell membranes. And acidity regulators, these are resistant to pH modulating agents, which is critical for surviving in the acidic environments. So these acidity regulators, they, whatever the additives are there, they need to survive in the acidic environments. Oils and fats, sometimes in advanced delivery systems, generally we will use liposome-based delivery systems where lipid-based carriers are used, such as surfactants, and they challenge the probiotic stability. So stability is very, very important. So whatever the oils and fats we are selecting for additives, they won't show any effect on the probiotic nature. And then thermal tolerance. Additives in heat processed foods require strains that can withstand the high temperatures during productions. So in the processing of these probiotic food products, sometimes the products while processing, they will undergo various temperatures, they expose to various temperatures. So these additives, they can withstand the high temperatures during the production of these probiotic strains. So probiotic viability can be affected by preservatives and additives due to change in the pH, osmotic pressure, and oxidative stress. These are the three important features which affects the probiotic viability. So certain additives may inhibit the probiotic growth, while others like prebiotics, they enhance the probiotic growth. So for example, calcium arginate beads, they have been shown to preserve the antimicrobial activity of the probiotics during storage. This is the positive effect of the additive, which enhances the antibacterial activity of the probiotics while storing the probiotic products. And these are the various examples of additives and preservatives. We see citric acid, generally vitamin C. This prevents the fruit or your fruit tart from browning. And then sunflower lecithin is used to prevent your almond milk from separating in your coffee. And then calcium disodium ATA, this prevents your mayonnaise from spoiling. And then sorbic acid keeps your wine free from fungi, bacteria, and yeast growth. And these are the various examples of preservatives. Those are sorbic acid, soft drinks, yogurt, and then benzoic acid used jams, creams, sulfites used in wine, vegetables, and drinks, diphenyl used in fruits, in cheese, examine, that is fish, and then propionic acid is used in bread. So these are the various preservatives used for preserving various food and dairy products. And another aspect is the compatibility with encapsulation materials. So nowadays, the probiotic formulations or the probiotic products are encapsulated and prepared as a form of capsules, and these capsules are available in the market. So here, one aspect we need to consider is that compatibility with encapsulation materials. So encapsulation, why we need to do this encapsulation means it's a strategy to protect the probiotics from harsh conditions. What are those harsh conditions? Those are nothing but acidic nature and then bile salts and improve their delivery. And materials like alginate, pectin, and other biopolymers are commonly used. Recent advancements focus on enhancing the encapsulation techniques to maintain the viability during processing as well as the release. These are the various examples of encapsulation materials. You can see the carbohydrates, proteins, lipids, and waxes. Under carbohydrates, cellulose and derivatives are used, chitin and chitosan, starch, agar, alginate, carrageenans, gum, and pectins. Under proteins category, these are the various encapsulating material, gelatin, congein, wheat gluten, soy protein, and whey protein. Lipids and waxes, you can see the waxes and paraffin, esteroglycerides, and shellac resins. These are the various encapsulation materials and then encapsulation methods. If you see here, carbohydrate materials generally spray and freeze drying, extrusion, coaservation, and inclusion methods are used. Whereas for cellulose, preservation, spray drying, and edible films formation is there. The gum spray drying and method syringe gel bits are prepared. Lipids, emulsion, liposomes, and film formation. And then proteins, there are emulsification and spray drying methods. These are the various encapsulation methods used in the formulation of probiotics. And another aspect is the interactions with stabilizers and flavoring agents. To see stabilizers, they can influence the survival and functionality of probiotics in food matrices by maintaining the consistency and protecting against the environmental factors. These are the various examples of stabilizers used in various food matrices and their purpose. You see, exopolysaccharides, they are used in the yogurt, cheese, fermented cream milk-based desserts. Gelatin is used in corn milk yogurt for maintaining the firmness. And then gum is used in yogurt for maintaining the firmness. Locust bean gum is used in ice creams for viscousness nature. Pectin used in yogurt for compactness. Xanthan is used in yogurt for firmness. Beta-lactoglobulin is used in dressings for creaminess. And carrageenan is used in vanilla ice cream for reduction of hardness and iciness. So flavoring agents, depending on their chemical nature, might impact the probiotic stability and positively or negatively. So a lot of studies have performed and they highlight the need for compatibility testing to ensure the probiotic viability without compromising the sensory quality. So we need to do these studies to maintain the quality. And then strategies to enhance the additive tolerance. So one is the strain selection. So when you are selecting any strain, so it has to show the resistance to specific additive what you are using in the probiotic food formulation. So you have to see the strain which is a resistant one. Then microencapsulation, and then this microencapsulation technique protects the probiotics in a biopolymer matrix to shield against harsh additives. And then adaptive evaluation, this is the gradual exposure of strains to additives to develop the resistance. This is the one laboratory method nowadays used for developing the new varieties of strains which can withstand the additive resistance. Then prebiotic integration. So you can combine these probiotics with prebiotics to boost their survival. So prebiotics acts as a substrates for the growth as well as development of the probiotics. So tolerance to additives is a critical consideration for maintaining the probiotic efficacy in diverse formulations, ensuring both product stability and health benefits. Thank you.